Hi friends, welcome to my channel. I hope everyone is doing well. Today we are going to solve another interesting matrix coding problem. It's on Leetcode 2069 Walking Robo Simulation 2. So this is another quite interesting problem that I came across. So I would like to explain this problem to you guys along with the logic as well as the solution in today's video. If you are new to this channel, please subscribe to this channel now. Your subscription is really valuable and important for this channel. It really helps and supports this channel. So let's start. A width into height grid is on a XY plane with bottom left cell as 0, 0 and top left at width -1 and height -1. The grid is aligned with the four cardinal directions north, east, south and west. A robot is initially at 0, 0 cell facing east. The robot can be instructed to move for a specific number of steps. For each step, it does the following. Attempts to move forward one cell in the direction it is facing, right? And if the cell of the robot is moving to out of the boundary, then the robot instead turns 90 degrees counterclockwise and retries the step. Okay, so it moves 90 degree but counterclockwise, right? So what it means, so if the robot is going like this, right, then let's say it hit a wall or something, for example, then it will change its direction counterclockwise, so it will start going like this. Okay, when it hits here, right, what it will do, it will start going counterclockwise, means it will start going like this basically, correct? This is a counterclockwise 90 degree. When it hits here, right, then it will start going south. So this is the counterclockwise 90 degree. Okay, so now after the robot finishes moving the number of steps required, it stops and waits for the next instruction. Implement robot class. So now we have to implement a class. Okay, so robot int width and height initializes width multiplied by height grid with a robot add 0, 0 facing east. Okay, void step in num instructs the robot to move forward num steps. Okay, and get post returns the current cell the robot is at, which is the array of length to xy coordinate of the robot, right, the get position. And the get dir is the get direction, returns the current direction where the robot is going basically, right? So four answers can be possible, one of them, right, north or east or south or west. So we will take this example. Width and height can be maximum 100. Okay, and num can be between 1 to 10 raised to 5 inclusive. Okay, so they are going to test the calls based on these different methods. Okay, so that's fine. So we are going to understand this problem better with this example. So as you can see here, we have actually a matrix which is 6 by 3. So 6 is the width, this is the width, and 3 is the height. Okay, and you can say that this is a xy coordinate. The robot is here in the beginning, which is a 0, 0th location, correct? So first we will initialize this with 6 by 3. That is the first step, correct? Now what they are saying is step 2. So you are going to, first your directions is at east, right? So you will go 2 steps. So you will reach here, correct? 2 steps you are going towards east, correct? Okay. After that again, where we are getting these 2 steps, this is given to us here, right? So after, so first 2 steps you went here, now again you are taking 2 steps forward, so you will reach here. Okay, so you will reach here, fine. Okay, now you are getting the position. So what is the position right now? 4 comma 0. So you will answer this 4 comma 0. Okay, so get dir, what is the direction? East, so you will answer east, right? Get dir. Okay, now you are going to take step, right? Step, and null. So null means uh, what, like what? Null means what? So let's take a look what they are saying actually. So take steps 2, we have done that. Take steps 1 and steps 4. Oh, 2 1 4, so it did not copy actually, so it's 2 1 4. Okay, sorry about this. So it did, yeah, here, right? So step 2, so step 2, I was looking at wrong place. So step 2, so you are taking 2 steps, so you will go here. So this is very important now. Okay, this is very important, that you are hitting a wall here, right, kind of. So now where should you go from here? because you once you go here you have to turn 90-degree counterclockwise. So you turn 90-degree and then you will reach here when you take 2 steps from here, right? So you reached here, basically here, correct? Okay, after that what you are doing, you are taking 1 step, so you reach here. Okay, fine. Now you are at the end, correct? Now you cannot move forward, correct? You are going north. You understood, right? You are going north, you cannot move forward. So now you are taking a 4 steps basically, but you cannot go forward. Then you have to turn counterclockwise. Where you will turn? So you will start going in this direction. How much you will go? 4. 1 2 3 4. So you will reach here. Okay, and then you will have to get the position. The position of this is 1 comma 2. So 1 comma 2, correct? And then the direction of this one, currently you are going west, right? This is west, so you have to answer west. So this is what the problem is. So now you understood this problem clearly, I hope, with this example. So pretty straightforward to understand and pretty clear to understand. So now how can we solve this problem? So what we will do is, to solve this problem is, we will define constant directions, right? So east. So first, always remember, this is a very important thing to understand, that uh, always this robot will first go which direction? It will go east, always. Okay, always. Whenever it hit a wall, it will always go north, always, right? North. Okay, whenever it hits a wall, it always go west, right? And whenever it hits a wall, it always go south, correct? So it will keep repeating this. Once it comes back, so you are, let's say here you took south, right? South. When you hit here again, you will again follow the same directions, right? East, north, west, south. East, north, west, south. So that's what you will do basically, correct? Okay, so this is one important thing that you should understand. Okay, once you understand that, then you have to understand that, um, if let's say, how many total steps that robot can take. So let me remove these colors. So in this matrix there are total, how many cells are there? 6 multiplied by 3, because this is a 6 by 3 grid, right? So total maximum cells in this matrix are 18, that you can see here in this picture, correct? You can see in the picture that 18 steps. Okay, now what is the maximum steps it can take, and it will come back here? It will be 14. Why? 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. So 14 steps when it takes, it will come back to its original position. You agree or not? Okay, I shown you that. Now you have to remember that if someone asks me that robot should take 16 steps, so I can directly, what I can do, I can just do 16 mod 14, right? Mod 14, and then I will get 2, correct? So it's very difficult to write here. So 16 mod 14, I will get 2 here, right? I will get 2. So this is 2, right? Okay. So it means that I don't have to go 16 steps and again go 2 steps, right? Because I will just directly calculate that 16 mod 14 and I will directly go here. You understood, right? Or someone asked me that robot has to do 30 steps, and where will it reach? Then I will just do 30 mod 14, and which is equal to 2. Again I will reach here, right? I don't even have to go there, right? Or like, I don't have to go these rounds basically and again go these rounds, right? Because I can do mod operator. That's what my point is. You understood this, right? Okay, so this is clear. And how will we know this 14 for a large matrix? I can know that because always the number of cells that you have to always subtract 4 from it, basically, right? You subtract 4 from it. So I'll leave it to your exercise that you can try on bigger matrix, but you will know that you have to always subtract 4, and that is the maximum steps you have to take so that you can come back to your original position. Okay, so just subtract 4 and then we will use it as a mod operator, so that we don't have to actually keep calculating, like keep doing it like actual steps basically, correct? Okay, so that is one thing. And I already told you the direction logic, right? So the direction will always start with east and they will keep repeating once your round is complete, right? So for example, how it will get repeated? So you start east, right? This is east, then this is north, this is west, this is south. Again same thing, right? East, north, west, south. So you will keep repeating that direction again and again, so that will not change. So that's, I'll show you that is pretty easy to implement. So it's and obviously we have to, for the position we will have to keep track of the x and y coordinate. So we'll create one xy coordinate logic, and we will create one variable d to keep track of the direction, right, where the direction is. And as I told you, the direction after one round it will keep repeating again and again, so you don't have to you can just use that logic basically to find out what is your current direction. Okay, so now that's it pretty much. So we'll go through the code and then I will explain you more there. So let's go to the code. So this is our code implementation for the robot class. So now we are going to take couple of variables here. So you must be knowing, if you are a Java developer, so private static final, it means that this is constant. So these are the directions, right? So what are these directions? So east is 1 0. So why 1 0? Because, so let me remove this. So if I have a matrix like this, right, I have a matrix like this. Let me draw something quickly here. So let's say this is my matrix, right, and I am here, right? Let's say I am here. So if this is my I and j coordinate, or x, y and y, whatever you want to say, right? So when I want to go here, what is this? This one is that, or let me call x and y only, so that it will be more appropriate for this example. So this one is a xy coordinate. If I want to go here, what I will do? X plus 1 and y, correct? X plus 1 y, right? So that's why you see here the plus 1 and 0, right? So I'm adding 1 to x and 0 to y basically. Okay, so this is clear to you. If I want to go here, what I will do? X minus 1 y, right? X minus 1 y. So it means that that is a west, so minus 1 and 0, correct? That is west direction. Okay, what about the north direction here? Then I will do, what I will do, I will add 0 to x and I will add 1 to y, correct? This is the north direction. So north direction, so 0 to x and 1 to y, correct? And for south I will add 0 to x and subtract 1 from y, correct, to go here. Okay, so this is what the direction is. Okay, so you understood this dir, and direction is the constant for the directions, because these directions is always east, north, west, south, right? So I shown you that, correct? So I'll show you how we will use it. So I'll create some variables here, width, height, for the matrix width and height, x, y, d and mod. Okay, so we created 4 variables. This is the constructor for the class. Width and height is given to us, so this dot width is equal to width, this dot height is equal to height. So mod is the one that I shown you how we calculated this 14, right? So total cells minus 4 is going to give us the mod, because we will use that mod, correct? So that's what I'm calculating here, width into 2 plus height into 2 minus 4, and this one should give you the mod. Okay, and is valid is a method that will check if your current cell is valid or not. So when will it be valid? If x should be greater than equal to 0, y and x should be less than width, right? This is one condition. The y should be greater than equal to 0 and y should be less than height. If that happens, then that is a within the matrix, right? That cell is within the matrix and that is the valid cell, correct? Okay, after that, this is very very important. Now step method, right? Actually the robot will walk that number of steps, right? So I'll take this number of steps num and I will do a mod to it, right? Because I shown you why we are doing mod, right? Because maximum take steps in this case he can do is 14, right? If you have more than 14, then you don't have to actually walk that, you have to just do mod basically. For example, 16 mod 14, 30 mod 14, and whatever is coming here, that's where you will land up basically, right, after you walk those many steps, for example, correct? So that's why we calculated that num mod, right? And if it is 0, it num is equal to mod, basically 0 means, correct? Okay, so this logic you understood. Now while num minus minus is greater than 0, right? So now we will start simulating that he's actually start walking basically. Okay, he will actually start walking. We are simulating, and we will first thing check if it's a valid cell or not, right? If it is a valid cell or not. What cell? We are adding dir d comma 0 and dir d comma 1 to y, correct? So x will become new x, y will become new y basically, correct? So for example, so when you take one step, your x will be incremented by 1 and y will be incremented by 0. When you take next step, x will be again incremented by 1, y will be incremented by 0, correct? Because why like that? Because you are going east, correct? When you hit here, when you are this point, what will happen? Your y will be incremented by 1 and x will be incremented by 0, correct? So that is what we are doing here. So d is equal to d plus 1 mod 4. Why we are doing that? Because the direction will change, correct? So I shown you this here. So direction right now is 0. Dir is 0. 0 is for east. In this, where this 0 is coming, this is because of this array. So this is an array, right? Direction. So 0 is east. After east, what will happen? You will go to north. 1 is north, right? 2 is west and 3 is south. So 1 is north. When you go here, right, your d will be changing, right? Your d will become 1 automatically. Why automatically it will become 1? Because of this, right? Because you are going out of the boundary, so you will increase your d and you will do mod 4 so that it will remain in that range of 0 to 3, correct? So you are changing your direction here. So this is a very crucial thing. Okay, so you understood this. After that, you will just add your dir d0 to your x, dir d1 to your y, correct? And you get new x and y coordinate, correct? And then you will keep looping in this while loop, and you will keep simulating that your robot is actually walking. Okay, so he will go north. Then once he hit here, again your d will be incremented to 2, right? D will be incremented to 2. So what will be your direction? 2 means west, correct? Then you will start going to west. This is the west. Okay, so that's what we are doing. Okay, so after that, this is just to show you, and that's all basically. So this is the step method, right? So your x and y will be incremented and updated accordingly. Get position is just simply you have to return the integer array of x and y, and that's all basically. And get direction is direction of d. D is available to this class here, right? D we created here, d. So the d will tell you which direction. So d can be 0 1 2 3. So that will tell you what is the current direction of the robot, right? So let's give it a run and make sure this code is compiling without any problems and running against the test cases. So as you can see here, it has passed the test case correctly and it's giving us correct output. Submit this code now to the Leetcode. Make sure this code gets accepted by the Leetcode. So as you can see, the code is successfully accepted by the Leetcode. So this is the way you can solve this coding problem 2069 walking robot simulation 2. Quite interesting matrix related coding problem that we have solved with this logic that I explained you with this example. So I hope that you completely followed this example and you understood this logic as well as the mod operator logic and the direction logic. If this example helped you understand this problem in an easier and better way, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is really valuable and important for the channel. It helps and supports this channel. Guys, it takes a lots of efforts to create these images. It takes a lot of creativity, time and efforts to come up with these examples and explain these examples for you. So if you really want to appreciate our time and efforts on this, then please subscribe to our channel right away and click on the bell notification icon button so you won't miss any interesting videos like this where we explain with whiteboarding sessions how to solve different problems. Share these videos as much as possible with your friends so they will also watch and learn from these videos. If you plan to learn more data structures, algorithms and how to apply them in programming and computer science problem solvings, then the important playlist for you on this channel includes graphs, matrices, binary search trees, binary trees, problems solved by using important techniques such as binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices and trees. The important data structures playlist for you on this channel includes stacks, priority queues, min heap, max heap, arrays and strings related problems are also solved and explained. Those are previously asked coding problems by big tech companies such as Amazon, Facebook, Apple, Microsoft and many other companies. So make sure you go through them, understand those problems. They will help you in your problem solving techniques improvement as well as in your coding skills. Thanks for watching this video and have a great day ahead.